Interface inheritance is similar to implementation inheritance in this regard when you have multiple objects that share the same basic shape. In other words, when they support the same method signatures or properties, they can be used interchangeably or polymorphically. Again, polymorphism, next video, get to that in a moment. But interface inheritance takes this whole idea one step further. We've already talked about interfaces as contracts previously, right? Interfaces only define the public members of a class that must be implemented by a class in order to satisfy a contract between two or more objects. So it's a contract of communication. There's no implementation to fall back on when you create an interface. Like there is with implementation inheritance that has, you can always rely on the parent's implementation of the display method, for example, or one of the properties that it's implemented. And so why didn't they create interfaces that way? Why can't you fall back on some default implementation? It's simple, because interface inheritance has a whole different purpose. And while it's similar, its purpose is different, I guess is the point I'm trying to make. You use interfaces to define an abstraction that breaks a dependency. I'll discuss this at more length in a couple of lessons when we talk about the nature of relationships a little bit more deeply. But in a nutshell, an interface represents a contract for services that I need rendered, or speaking as an object, I need something done. So I will put a contract out there and say, if anybody can work with me, here's the contract that you will have to fill on your side. You have to satisfy on your side. So the other object can accept the terms of the contract and say, hey, I can help, I can do that, and I've already gone and implemented the terms of your contract, so you can go ahead and use me to do whatever you need me to do. And so maybe a little bit of code here would help to kind of you to see that communication, that realization. So let's start off with two classes, and I'm going to start off with a book class and a car class. So we'll make it really simple here. Public class car, and prop tab string make, prop tab string model. Okay, and then let's go ahead and create a book. So public class book, and let's just say that we have a title and an author. We won't make this very hard. Okay, great. All right, so now let's go ahead and implement, or actually create instances of our two new classes up here in static void main. So we have var car equals new car, and let's go ahead and give it its make and model right here. Make equals GMC, and the model will be a Yukon. And then let's go and create a book equals new book, and we'll set the title equal to 1984, great book, and set the author equal to Orwell. All right, and then let's go the obligatory console.read line down here at the bottom. Great, save all that. Awesome. All right, now let's go ahead, and we want to actually print out these details to screen. Let's start with a little bit of, you would never want to do this. So I want to print out the car, and I want to print out the book. So I might create two helper methods, one to print out a car, one that knows how to print out a book. So let's go static void display car, and it's going to take as an argument a car. And just so we'll stub this out, static void display book, and we'll go book, we'll pass in a book, right? And so here we'll go console.writeLine, and string interpolation, I love it. Okay, And so we'll go car.make and car.model. Get rid of that. And then same sort of deal here. In fact, here, let's just grab that, paste that here. We'll go boo. Let's go book. Author and book dot title. Awesome. Okay. All right, so now let's call those methods. Let's go display car, and we'll pass in the car. And I can't type today, unfortunately. Display book, and type in the book. All right, so now let's just run it. It'll be anticlimactic. This is such a simple example. Let's not get hung up, however, on the simplicity of the example, but the concept that's being illustrated here. So at this point, what happens when I want to add another type of object? Maybe I want to have t-shirts or computers or even microphones or food of some sort. I would have to come in and create a new helper method for each one of these, and this seems like not the right place to do that because this code passage could get longer and longer and longer over time. What I really would like to do is say, hey, you know what? I'm done with taking on the responsibility of printing. That's not really my job. First of all, I don't even have the information necessary to go off and know what needs to be printed and how it needs to be printed. I'd rather have the information holder, the object that knows the information, be the one responsible for formatting and then printing out to screen the value inside of its own instance. All right, and so what we can do is say, I tell you what, static void main says, I tell you what I need. I need to create like one method here. In fact, let's just call this static void display yourself. Okay, that's kind of a crude name, but that's essentially what we're looking for. And what I need to do is say anybody who can be printed should be printed. So I'm going to create a contract and say if you want to be able to print yourself, then you need to implement iDisplayable, which I don't have defined yet. So let's go ahead and create a new contract. So public interface iDisplayable, right? And all you got to do to satisfy this contract, all you got to do is just implement one method called display. See how easy that would be? No problem whatsoever. And then you implement display for yourself, and I'll just call you when the time comes, okay? So here we say if you want to be displayed, you're going to implement iDisplayable. And we'll just call this my object, something, my displayable object or something like that, right? We'll just keep this simple. And then it just becomes a matter of saying my object.display. Now how did it know in IntelliSense to give me the option for display? Easy. There's confidence now, strongly typed confidence that any object passed into this display yourself method must have implemented the display method. So it has confidence knowing that it'll have that type. So now what we can do is just get rid of this, get rid of that, and we'll go display yourself, and we'll say car, go display yourself. And then we'll say display yourself book, go off and do it, right? And yet we get red squigglies. And why is that? Because those two classes do not yet implement the contract. At this point, they just became aware that a contract even exists. They're going to go have to do some modifications to how they work. So in this case, I'm going to implement iDisplayable. And I'm going to get a red squiggly line, And if I hit Alt-Enter on my keyboard, because I'm using ReSharper, it'll ask me if I want to implement missing members. I'm going to go ahead and say, yeah, go ahead and do it. And so it creates a stubbed out version of this public void display. Notice that it will throw a not implemented exception. However, no red squiggly lines anymore. In fact, if we go back up here to the top, notice car no longer has a red squiggly line under it. Why not? Because it now implements iDisplayable. Now, if we actually call it, it's going to throw a hissy fit, right? Because right here we've got an exception going to be thrown. Let's go and delete that template code and just go, in fact, here, we can make this real simple on ourselves. We'll just do this. In fact, we don't even need the word car. We could do this, or we could just get rid of that altogether and just do that, like that, right? Either way is acceptable. ReSharper suggests that we don't use this, so we'll just do that. And then we'll do the same thing for book. We'll say book. I want to be displayable. I want to offer my displaying services. And so here, once again, hit Alt-Enter, implement missing members. I'm going to get rid of that. And I am going to grab this now deprecated code. I'll remove it from my project here in just a moment. And here we'll just go get rid of the book reference, and that should work just fine. All right, so now book and car implement a contract iDisplayable, and they're both able to be passed in. You have one method that can display yourself, and now let's just go ahead and comment out these original implementations of display. And let's run the application. The result won't be any different, but the way that we got there is dramatically different. Now, what happens if we want to create yet another object? Public class, let's call it computer, right? I probably shouldn't use that word. Let's call it t-shirt. That'd be better. And so t-shirt will have a size and a color. Let's just say that. Prop int size, prop string color, and I know I want it to implement iDisplayable. Oops, right line. And we'll go, just call this t-shirt. And so we'll print out the size and the color. Okay. And now what we'll do, let's see, we have a blue squiggly. Oh yeah. Let's go ahead. It makes a good point. T-shirt, the letter T sometimes, whenever you name things, it has a different connotation. Let's get rid of the T and just call it shirt. All right. Thank you, ReSharper. Thank you for the naming suggestion. So let's come up here and now create an instance of var shirt equals new shirt. And we'll give it a size equals, I don't know, size by like chest size, I guess, and color equals black, because that's just how I roll. And then we'll say display yourself, right? And now, from this point on, the program class doesn't need too much information about how to display objects that it holds a reference to. It is going to depend on the fact that they implement this contract and that they know how to display themselves as a result. And so the information holder in this case, the one that knows how to do the work, is assigned that work in this case to actually display itself. All right. So at any rate, like I just demonstrated here with shirt, any object that implements a contract can be used. Since any object that implements a contract can be used, that means two things. First of all, that we've removed a tight coupling that our object, in this case the program class, may have to other objects, like, for example, book, car, and shirt. We really see that more here in the display yourself. There's not a tight coupling like there was when we had display car and display book, tightly coupled to individual classes, right? And we don't have that anymore. It's just very generic and we can pass anything into it. So that's the first benefit. And then the other implication is that since our object is not coupled and only depends on a specific coupled in such a way that it depends on a specific object type, but now any object that implements our iDisplayable contract, we can isolate our object more easily. So if we wanted to unit test main, for example, if this were a different type of object, we could isolate it and then perform unit tests on it and make sure that it abides by the fine print of the contract. And we're not going to demonstrate that here. In fact, in the next course, object-oriented programming course, we'll see more of that at play. But any rate, let's talk about why is interface inheritance important in the whole scheme of things. Why is it one of the tenets of object-oriented programming? Well, similar to encapsulation, it keeps our collaboration simple and flexible because we've established clear boundaries. We don't want one object so tightly coupled to another object like we've done right here that it would require us to change both objects whenever there's a change needed to one to some piece of information. So, for example, if I wanted to change the car class and add public int year, get set. All right. So now, in the old way, I would have to come up here and also make a change to display car to get that implemented. But I'm making a change in two places. That doesn't make as much sense as just making the change here, like inside of the display method for the car, right? Now, again, we are creating instances up here, so I would still have to, as we create a new instance of car, I'd still have to give it a year, but that's kind of a different thing. That's object creation rather than, and somebody's got to do that at some point. It just happens that this example is so simple that I kept it in one spot. But now the application still works, and I didn't have to change both my display function here in this object and my object that I'm displaying here. I'm just making one change just to the car itself. All right? So now that there's an established contract, we can break the direct dependencies between collaborators. To coin a phrase, when one sneezes, the other one doesn't catch a cold. So interface inheritance helps us to separate our concerns in clean lines. And again, we'll talk more about that in a couple of lessons when we talk more about relationships and dependencies and how to reduce coupling. All right, so let's continue on. Pick it up with polymorphism in the next video. Thanks.